Tumor necrosis alpha, this is really important for the diet. Tumor necrosis alpha is something your body makes in relation to some kinds of immune challenges. One way you can trigger them is by bacterial exposures. Now in the lab, if you want to have a bacterial exposure, you don't want to have bacteria in your lab. So what people do is they use this stuff called lipopolysaccharide, LPS. And that's something from cell walls of bacteria, but it's not infectious. So, but the body reacts as if it was the bacteria. So they injected this into some rats, and they measured tumor necrosis factor alpha. The tumor necrosis factor alpha went up. In the bloodstream, it stayed up for 9 hours. In the liver, it stayed up for a week, and in the brain, it stayed up for 10 months. What this says to me is if you're on a careful diet and you cheat, you're reactivating the brain inflammation in an area that's not going to get over it for quite a while. So if you go try a diet, you say, oh, I took my kid off of wheat for a week and nothing happened. It doesn't work like that. It takes a long time to get over it, and it's pretty easy to screw it up. So I think that this is a really important finding that is about how we take care of ourselves and how it's not a joke to cheat on your diet. So now here's some stuff that I actually, it's a whole lot of words, but so people are getting it, there's some kind of environmental role in autism. But it's only in the last few years that there's been any money given to actually study this. So we're still making inferences. And I've already done this a number of times in this talk. We know that there are environmental things that affect many things in autism. Many brain functions, body functions have been demonstrated outside of autism to have this impact. But little or no demonstration of direct insult in autism. And also in treatment, there are many treatments that people are using that in other areas have been documented to have some kind of impact, but not always in autism. And this is a slide that my colleague, Mark Corrales, made. And he works in the CPA, God bless him. And he is a remarkable he's a genius at searching literature. He uses computational methods to plow through literature and do counts of it. Like we had 2 posters last year, I did with him, looking through all 12,000 papers of autism that have been published to date and what they're about. So, like we know that the toxins can mess up your cells, your biomarkers, your genes, your brains, and various behavior, but very little of this has been connected to autism. So we're still saying, well, we know this and this, and we know this has this, but even though we didn't prove the connection from here to here, we're assuming that there's a connection. So that's not bad for a start, but we need to do better than that. Now, here's a statement. There was a paper a number of months ago about hyperbaric oxygen treatment by Dan Rossini. And the press commented on it. And here's a statement that was in one of the press reports that was not attributed. This was like the reporter wrote it, didn't attribute it to anybody. Nevertheless, cerebral hypoperfusion, and I didn't talk to you about this, so let me stop for a second. Hypoperfusion has to do with less blood flow in the brain. This has been documented in 17 out of 19 head inspect papers that have been done in autism. But the problem is in each study it's been in a different part of the brain. So people say, well, it doesn't explain anything. But if they're all less, it's just about all less. Now, interestingly, oxidative stress regulates blood vessel, how big the blood vessel, whether it's going to constrict or be big. And these astroglial cells, the ones that are swollen up, they're bigger. And when they're bigger, they cramp down on the blood vessels, and as much as 50% reduction of blood flow to the brain can occur. So there's a lot of reasons microglial cells can encircle blood vessels. So there's a lot of reasons that the tissue changes, the cell changes that I've been telling you about, can be associated with low blood perfusion. If you have less blood perfusion, you're not going to be able to do, you're not going to have as much oxygen. You won't be able to your cells are going to be like, I can't deal with this. I give up, or I'm just going to really have to go into first gear because I can't get it to second gear, let alone third. So nevertheless, so this reporter says based on probably what a bunch of people told us, cerebral hyperperfusion remains out of the mainstream of scientific thought. Like, who gets to say that? On the source of autism, which is now focused on various genes and varying gene and environmental factors that combine to impair development in childhood. So what's wrong with this statement? So I'm going to tell you. Does anybody want to tell me what's wrong with this statement? Is it irritating? Yeah, well, what it does is it confuses cause with mechanism. So you're looking at the genes and environment. Then you've got invariant development. Well, how are the genes and environment doing that? It's assuming that the only thing they're doing is messing up early development, the blueprint. So we've advanced from genes causing brain damage to genes and environment causing brain damage. And the so-called mainstream of scientific thought is not looking at the mechanism as something active, being caused every day by things we might be able to address and heal. They're just assuming, the masked man came in and did the damage, and that's the end of it. So this is a diagram of what I'm just saying. Genetically caused static encephalopathy is the model that I was taught when I got into this field, and I'm diagramming it. The cause is the gene. The mechanism is an early developmental change, and the impact is a fixed functional deficit. You're toast, forget it. Model 2, gene environment caused static encephalopathy. So you add environment. Now environment gets to be one of the causes of screwed up wiring diagrams. You're still toast. So that is, I think, where the mainstream has gotten from the gene, and now they're mostly talking about early environment. But they're talking about it in this way. So, all right, that's not bad. It's better than it was. So we're stuck at the first step before. Now we're stuck at the second step. So there are 2 more steps. So epigenetically altered genes. So now you're not having genes necessarily. So now we're talking epigenetics. It's still environment. It alters the gene expression. Different ones are turned on and turned off. You can have what looks like a fixed functional deficit, but you can also reverse or change epigenetics through lifestyle modification. And this is known. Not easy, but you can do it. Finally, later, an ongoing environment. This is what I think we need to be thinking about more, which is that the environment is the gift that keeps on giving. You carry this body burden around with you, and it keeps messing you up actively. It's not just that it messes up your wiring diagram, it messes you up every minute of every day, every microsecond, because nerve signals happen on a microsecond scale, and it messes you up at that scale. If not even more tiny time scales at the cellular process level. So it alters neuromodulators, the things that modulate at the level of like that excitation inhibition ratio that I was telling you about. It modulates at that level every microsecond of every day. And this is something which you people in environmental medicine know about. They don't necessarily think about it so much at the brain level. Some of them do. And what that gives you is a chronic encephalopathy. Encephalopathy, encephalo means brain and pathy means there's a problem there. So a metabolic encephalopathy is something that you can have and it can go away. Like if you get drunk, you have a metabolic encephalopathy the next day, God willing, you get it. And if you drink enough water, you're in a headache. And so a dynamic encephalopathy